Let's see how we can calculate the moment of inertia of a complex object by splitting the object into individual components. So the problem at hand is the following. We have a machine part that's shown in the graph below, in the picture below. And this consists of 3 discs that are connected with lightweight struts. So the first part of the problem is, what's the body moment of inertia about an axis through the center of disc A? So right here. Then what's the moment of inertia about an axis that passes through the centers of B and C? So right there, this axis. And then finally, what's the body's kinetic energy of rotation when it spins about an axis through A? And the speed of rotation, the angular speed, is 4 radians per second. So to be able to solve this problem, I will consider the 3 disks as point particles, so they do not have dimensions, they just have mass. And so I will treat them as such when I'm calculating the moment of inertia of the entire system. So for a discrete system of objects, the moment of inertia is defined as the sum of mass of each object times the distance from the axis of rotation of each object to the second power. So then for the rotation about the axis that passes through A, the moment of inertia IA is going to be equal to the sum of masses times distances squared to that axis of rotation. So if you look at the schematic here of this machine part, we have the distances from B to A, from B to C, and from C to A, as well as the masses of C, B, and A. Furthermore, since the axis of rotation passes through A basically does not have a moment of inertia with respect to that axis of rotation, since it is on the axis of rotation. So that means that I only will have the terms for the masses of B and C, and of course the distances to point A, or to the axis through A, from B and from C, so our B squared and our C squared. Replacing with the values provided, we have 0.1 kilogram times 0.5 meters squared is equal to not equal but plus 0.2 kilograms times 0.4 meters squared, which gives us the result which is 0.057 kilograms meters squared. Part B of the problem asked to calculate the moment of inertia about an axis of rotation that passes through the centers of B and C. So right here. So that means that the calculation will only involve the mass of A and the distance from A to the axis B and C. So the mass of A multiplied by the distance between A and the axis that passes through B and C squared. So that gives us 0.3 kilograms times 0.4 meters squared. That is equal to 0.048 kilograms meters squared. The last part of the problem asks to calculate the rotational kinetic energy about the axis that passes through A. So that would be 1/2 IA times omega squared. So I've calculated IA already, right here. And I know the value of the angular speed is 4 radians per second. So therefore, I will replace these or substitute these numbers in the formula and find what the answer is. So 1/2 times 0.057 kilograms meters squared times 4 radians per second to the second power gives me 0.46 joules as the rotational kinetic energy of this machine part when it spins about the axis that passes through disk A.